Hello everyone, this is Safa. Welcome back to the AUV Fundamentals series. This is episode 2 and today we're going to take a closer look at the major components that make up an autonomous underwater vehicle. Understanding these components is essential before we move into sensors, kinematic and later MATLAB simulation. In this episode, we will discuss each of these components: the hull, the power system, the onboard computer, thrusters, sensors, and mission-specific module. These parts are from the basic architecture of almost every AUV. Okay, the hull is the outer body of the AUV. Its job is to protect all internal components, provide structure, integrity, and reduce drag in the water. The shape of the hull is extremely important because it affects stability, speed, and overall hydrodynamic performance. In deeper mission, pressure resistance is a critical design requirement. The power system is usually based on lithium-ion or lithium polymer batteries. Battery capacity directly determines how long a mission can last. Its weight, size, and placement also affect buoyancy and stability. Later in this series, we may simulate how power limits affect mission planning. The onboard computer is the brain of the AUV. It runs navigation algorithms, process sensor data, control the actuator, and execute the mission plan. Since underwater communication is limited, AUVs must make decisions autonomously. So, the onboard computer is absolutely essential. Thrusters provide movement. Some AUVs only have a single main thruster, while others have multiple units that allow precise 3D maneuvering. Thrusters efficiently and configuration directly influence in vehicle range and maneuverability. Later in this course, we'll model thrust forces mathematically in MATLAB. Sensors allow the AUV to understand its environment and estimate its position. An IMU provides orientation and acceleration. A dip sensor gives a vertical position. A DVL measures velocity relative to the sea floor. GPS can only be used at the surface, so underwater navigation becomes challenging. We will explore each of the sensors in detail in the next episode. Mission modules are optional components that depend on the application. For example, mapping mission requires sonar, environmental mission use a chemical sensor, and inspection mission may use cameras. These payloads also influence the vehicle weight and balance. Okay, let's look at a simple MATLAB example. These scripts show a hypothetical power consumption curve over time. Later in this series, we will build complete models that include thrusters, power, hydrodynamic, and sensor data. To summarize today's lesson, we reviewed the whole power system, computer, thruster, sensor, and mission module that's from an AUV. These components are the fundamental for everything we will simulate and model in later episodes. And thank you for watching episode 2 of AUV Fundamentals. In the next episode, we'll go deeper into AUV sensors, how they work, what data they provide, and how they affect navigation. See you in episode 3.